Okay, this is help on number 7. I had a couple of you guys ask about number 7, so we're gonna go ahead and apply the remainder theorem to all the possible rational roots. So to do this one, I need all the possible rational roots. All right, so for this one, let me do this really quick on this side. I'm gonna do the possible rational roots, which is p over q. So this is our p value, and this is our q value. Now, the answer is not 20 over 6, it's what factors multiply together that give me 20. Okay, so for example, I'm going to put over here p over q. Okay, to make 20, that goes on top. Well, I know that 1 times 20 is 20. It's even, so I know it's divided by 2. So 2 times 10 is 20. 3 doesn't go into 20. Oh, but 4 does. 4 times 5 goes into 20. Okay, so those are the factors of 20. Then I have to do q, and q is 6. So what factors, what numbers do I multiply together that give me 6? So I know 1 times 6 gives me 6. Let's try 2. Yeah, well, 2 goes into 6, right? 2 times 3. And that's it. So we're going to go through each one to get the possible rational root. So I'm going to start with 1. So I'm going to do 1 divided by 1, which is just 1. Then 1 divided by 2, which is a half. 1 divided by 3, which is a third. Plus or minus, it can be positive or negative. 1 over 6 is plus or minus 1 over 6. All right, so then I'm going to keep going. I'm just going to, next I do the 2. 2 divided by 1 is 2. Then I keep going. 2 divided by 2 is 1, but I already have 1. I don't have to do it again. 2 divided by 3 is plus or minus 2/3. And 2 divided by 6 is 1/3, and I already have that one, so I don't have to do it again. All right, now the next one is a 4. 4 divided by 1 is 4. 4 divided by 2 is 2. 4 divided by 3 is 4 over 3. 4 divided by 6 is 2/3, which I already have when I simplify it. All right, next one is 5. 5 divided by 1 is 5. 5 divided by 2 is 5 over 2. 5 divided by 3. I'm not simplifying these, I'm just going through them. 5 divided by 6 is just 5/6. All right, now I gotta do the 10. Okay, 10 over 1 is 10. 10 over 2 is 5. Do I have 5? Yeah, I do. I don't have to do it again. 5 over 3. Oh, I'm sorry, I'm doing 10. 10 over 3, which is just 10/3. And 10 over 6. 10 over 6, which simplifies to 5 over 3, which I already have. I don't have to do it again. All right, and the last one is 20. So 20 divided by 1 is just 20. 20 divided by 2 is 10. I already have 10 here. 20 divided by 3. Can I simplify 20 divided by 3? No. So 20 over 3. 20 divided by 6. I could simplify by 2. Which gives me 10 over 3, which I already have. I don't have to do that one again. So those are all my possible rational roots. All the ones that are possible, but they don't mean that they all are actual roots. All right, so I'm going to go back over here to number 7, and I'm going to use synthetic division in order to find if one of these factors up here are actually going to give me an answer or a root to this function, this polynomial. So I'm going to try one of my favorite numbers that you know is, let's try one like a 4. All right, let's do 4. No, let's do 1. I'm going to check it. So I'm going to use my coefficients for this polynomial in order to do this a little bit more quickly. So 6, -11, -57, and 20 are my coefficients. All right, so let's start. I bring down the 6. 6 times 1 is 6. and I have -5 when I add them. 5 times 1 is -5. -57 and 5 is -62. -62 times 1 is -62. I add those two together. -62 plus 20 is -42. So this is not a root because this is a -42. But this is actually the ordered pair 1, -42. Okay, so that would be, okay. So let me try another one. I did 1. Let's try another whole number. Let's do 4. 4 is yeah, let's do 4. All right, so once again, I'm going to do 4. So now I'm going to use synthetic division again to see if this is a possible root. So let's do this. Bring down the 6. 6 times 4 is 24. 24 and 11. -11 when you add them is 13. 13 times 4 is 52. 52 and -57 is -5. -5 and 4 is 20. Oops, -20. So when I add those two, yes, it gives me a yay, right? It gives me a 0. So that means this is a root. X equals 4 is a root. Okay? So because this is a degree 3, now this changes this guy to a degree 2. Plus x minus 5. So now I have this function. I'm going to write it up here. 6x squared plus 13x minus 5. Okay? And this one, I'm going to do the x game extreme. It's a quadratic. So let's use x game extreme. What two numbers? These two I got to multiply, right? 30 and, -30 and 13. Are there two numbers that multiply to -30 and add to 13? Well, 13 is prime. Oh, I'm sorry, 30 is not prime. I have to add to 13 and multiply to 30. Okay, so 3 and 10, but that wouldn't work. 15 and 2. All right, here we go. 15 and 2. 1 has to be negative. 15 take away 2 is 13. So this is perfect. But I have to divide both sides by my leading coefficient. So now I have to simplify. So this I could divide both sides by 2, -1/3, right? And this one I divide by 3, which gives me 5/2. Yeah, that's pretty simplified. And remember, it's number over x. So when I write it in factored form, it's 2x plus 5. And same thing over here. This would be 3x minus 1. Okay, in factor form. So to find the roots, I would have to set each one by the 0 property equal to 0. So here we go. -5 minus 5. 2x is equal to -5. Divide both sides by 2. So here I have x is equal to -5/2. Plus 1 plus 1. 3x equals 1. I divide by 3 equals 1/3. So these are the roots. So let's look up here if they were even. So I have 3 roots, right? I have x is 4 is a root, and these are my other 2 roots. 1, 2, 3. Let's look up here. Was -1/3 a choice? Yeah, it was. Was -5/2 a choice? Yes, it was. And was 4 a choice? There it is. Okay, so that is how you apply the remainder theorem. Once you already find one, and that's just guess and check. Now, if it doesn't work, this means that means 1 is not a root. In order for it to be a root, this needs to be a 0. This did not give me a 0, so this is not going to be a root. So then I just picked another one. I picked a 4. You could have picked a 2, and then maybe it would have not worked, and then gone to the next one, picked a 4. Okay? So that is how you complete number 7. If you have any more questions, send me a message. Okay, bye.